All right. Well, it is time, I guess, and the recorder has just started. Almost by itself, I put a timer next to it, so it's starting based on the delay. The first thing I want to do, somebody probably have received my email already about Holland Code. Yeah?
Yeah.
Okay. So Holland Code, I'm just going to go there first, because this class is a little bit ahead of my AM class, so I can afford to, spend a little bit of time on Holland Code. Holland Code, I'm just going to the Korea GPS part of my Moodle website. And this is something I prepared for Korea GPS, which is an event. Have I talked about Korea GPS in this class? No? Okay. Korea GPS is next Wednesday and next Thursday. It's basically an exhibition for employers and colleges, so that we can educate middle school and high school students about career options. It's not just for computer science. We also have all kinds of programs over there. But the objective, if you want to look it up, it's easy. You just look up Career GPS Cal Expo 2013, and that will give you all the information that you need about Career GPS. You probably don't need to go there because you already know what classes you want to take. But for middle school and high school students, this is a good exposure. But what might be interesting to even students in this particular class is to go to this link here and take this test. This is done by Rogue Community College. And what it is it's a personality trait kind of test. So you basically just have to look at all these questions. It's just yes or no. There's nothing like rate from 0 to 4. How well do you like something? So you can do it really quickly, or you can just do it slowly and accurately. So I'll just go ahead and pick something here. I'll just pick something randomly too. Okay, so what you do is you just try to answer the questions as truthfully as you can, not like what I'm doing right now. I'm just picking things in random. Okay, it's easier to do it with a mouse rather than a keyboard. Okay, you can see the questions really span across different types of assessments. Okay, so I have just clicked randomly some on the screen, and then you press the button, submit answer, and get your Holland code, and then it will give you. Yeah, mine doesn't look very good. It'll give you recommendations based on the Holland code or the personality trait assessment, and it will even tell you. Okay, so based on all the random picking, I'm artistic, right? And it also gives you the overall rating in each, basically in each dimension. So you can see that I'm very high in terms of social, which I'm not really the case, but since I randomly pick things, it just so happens that way. Investigative is also an 8. I think the highest you can get is a 10. So 8 out of 10 is already considered pretty high. Lowest is realistic. Great. And artistic is high too. Conventional is a 4. Enterprising is a 4. So it's a kind of interesting thing. If you answer truthfully, it probably would give you a realistic type of answer. And the answer is actually in the form of program recommendations. So in this case, because I am considered social and artistic based on all the random stuff that I pick, you can see that it's mostly artistic and creative type of programs that is recommended to me. So it's it's just something that you can do during your spare time, and I would take it with a grain of salt. But even so, it is not completely off base. So it probably has some merit to it, especially if you answer those questions truthfully. For some of the questions, if you don't know what the answer is, you can always ask friends. Okay, always ask people who know you and say, okay, do you consider me blah? Okay, and then just if 3 out of 4 people say yes, you are, then just click check it. Again, I'm not trying to use this to discourage people from, continuing with this class. So even if you score very low in terms of, investigative, which is a very, important aspect of programming, it's okay because, it's just, one data point. It may not be representative of actually how you are. Aside from that, I got good news. The dean has answered my question, and he said anyone who wants to add to this class and who has been attending the class consistently since the beginning can now add to this class. So what you need to do if you're trying to add to the class, whether you're on waitlist or not, doesn't matter. You have to go to the administrative building, get 2 forms. You have to get a regular add form and get a petition form. Get 2 forms. Fill in as much as you can, okay? So the course code and stuff like that, you have to fill that in. And then on Thursday, bring it to the class so I can finish my, portion. And then the dean, will be here on Friday too. If not, he said that he will sign forms, this week, and that's it. This is the last week he will sign those forms. Okay, so for those of you who are waiting to get into this class, it's good news. But the condition is, I have to be able to see that you have been attending classes consistently since the beginning in order for me to sign that form. Okay, which is also a requirement from the college itself. All right. Any questions about that part? Questions? Okay. If there are no questions, the first thing I will do, which is typically what I do in my classes, is I'll go over the homework assignment that was due at 7 p.m. So that's about 6 minutes ago. And what I want to do is to basically show you how I would do this homework assignment. And the way you do it, should be very close to the way I do it. Okay? And I'll kind of point out, how or where you can have some deviations and where you cannot have deviations. What I would consider incorrect or have points taken off when a answer is not the same as mine.
Can we have the sign-in sheet there?
I will have the sign-in sheet in just a moment. So I think people are still kind of streaming in, so I'll let people settle in a little bit. Okay, so this is your homework assignment, and I'm going to do the homework assignment myself. What you want to observe is, 1, which line numbers I put on the line number column, because that's important. The second thing is, whatever I put in a comments column, you have to have that too. Okay. Now you can have additional stuff in the comments column if you want to say, oh, this is an assignment statement, and therefore variable blah is getting updated. That's okay with me. But what I'm going to show you is the minimum. Okay. And of course, the values of variable x and variable y, they also need to be updated, basically the same way as it is updated here when I'm doing this. Do you guys have any questions? Anything I can answer? Nope. Okay, so let's go ahead and take a look at how I answer these questions. All right. So we start with line 1. X gets a value of 0. No big deal. That's pretty easy. Line 2, not an issue either. We have to indicate x is less than 20 is either true or false. In this case, because x has a value of 0 currently, 0 is less than 20 is true. So this part is important. Okay, you have to indicate what the condition is, what is the condition that I'm evaluating, and whether it is true or not as an answer. So those two, they must be there. Whether you use is or an equal sign or missing something incompletely, just say x less than 20 true. That's okay. Okay, as long as I understand what you're writing and the condition is correct, that's okay. But it has to be here. Okay, some sort of indication of the result of the condition has to be here, because that will determine where I go next. Now, since this is a pre-checking loop and the condition is true, I have to get into the body of the conditional statement, which means which line am I going to? You go to line 3. Very good. Line 3 is the beginning of a conditional statement. It has its own condition to evaluate. So once again, we have x is less than 4, which is the condition on line 3. And you also have to indicate whether it is true or false.
True.
It is true. Very good. And then we go to line 4 as a result, because that's the then branch of the conditional statement. And line 4 is pretty easy. All it does is to add 1 to x. X goes from 0 to 1. Now where do we go? Okay, so you have to think, in terms of the structure of the code, where are we at this point? We are at the end of the then branch of the conditional statement, which is the only statement inside the while loop. So that means we're ready to get out. Do you guys have any questions?
No,
Okay, so please focus on what I'm talking about. So we have to remember where we are in the code. Okay, we are at the end of one of the branches of the conditional statement, and that conditional statement is the only thing inside the loop. So I'm running out of things to do inside the conditional statement because I'm at the end of one branch. And there's nothing else after the conditional statement in the loop. So I'm running out of things to do in the loop as well. So where do I go next? We go to line 2. Okay. In other words, I don't track and if, which is line 12. I don't track line 13, which is and while. If someone tracks line 12 or line 13 for this particular homework assignment, I'm going to say, okay, that's all right this time. So I'm not going to take any points off. But in future traces, and if and and whiles should not be in a trace because they don't really do anything. Are we still doing okay so far? Okay. Once we get back to line 2, we re-evaluate the condition x is less than 20. It is still less than 20. And then we go back to line 3. We re-evaluate x is less than 4. It is still true. We go to line 4. We add 1 to x. X goes from 1 to 2. Nothing exciting here. We go back to line 2. Same thing. Go to line 3. Same thing. Wow, this is going to take a while to get to 20 because if this is all we're going to do, we'll have like 80 rows to get to line. No, I take it back. 60. Yeah, we'll have about 60 rows of traces to get back to get out of the loop. But that's really not the case. Okay, so we get to 3. We go back to line 2. X is less than 20 is still true. We go to line 3. X is less than 4 is still true, but this is the last time it will be true. And then we go to line 4, we add 1 to x, x becomes 4. We go back to line 2, x is less than 20 is still true. We go to line 3, guess what? This time x is less than 4 is false. It is no longer true. So that means where we're going to go this time. We have to go to the else portion of the conditional statement, which in this case is on line 6. Okay, so we have to go to line 6 here because the condition evaluates to false. Okay. On line 6, we are not doing anything super fancy. We are just saying y gets a value of 0. Fine, we can do that. And then we continue on to line 7 because line 7 is sequential to line 6. It's really just the line after line 6. So we continue execution on line 7. Line 7 is the beginning of an inner loop. So this is not the same as the outer loop. This is an inner loop. At this point, the inner loop is independent of the outer loop. Okay, so when you trace the inner loop, it has nothing to do with outer loop at this point. So we have to write down the condition here. Y is less than 2 is true because it was initialized to 0. Then we go to line 8. And right now I'm going to show you one little trick here because I'm going to roll things out of the screen because I'm using a 1024 by 768 resolution, which is pretty low, and I can't really fit a lot of stuff on screen. Plus, I'm zooming it in too so that we can see more easily. So I'm going to do this trick here. You might find this useful if you have a smaller screen, if anyone is trying to use a netbook to do a homework assignment, or for whatever reason you have a lower resolution. You can drag this little bar here and just drag it down like that. And then now we have 2 vertical scroll bars, and one can scroll independent to the other one. Do you see how I just did that? Okay. No?
No, off the screen.
Okay. Oh, it's off the. Okay. Let me see if I can fix it. I can move this one over here. Now it shows. There we go. Okay, I'm going to do the whole thing again. So I'm going to drag it back up here. Okay. So this is what it was before. It's one single pane within that window. But what I want to do is I want to keep the heading displayed while I scroll the rest of the rows. So what I did was I put my mouse pointer over here until it becomes an up-down arrow thing. I drag it down like 2 clicks to have the separator 2 rows down, and then I release my mouse. So at this point, you can see there's one scroll bar here, and then there's another scroll bar here. The 2 scroll bars are now independent. I can scroll one part of the screen independent to the other part. So this way, I can still see line number X, Y as the column headings while I continue with this rather long trace. Is that okay? All right. So getting back to line 8, I'm not done with line 8. So we'll go ahead and do line 8 here. Line 8 is x gets x plus x, which means I am taking the current value of x, which is 4, and add it to itself. 4 plus 4 is 8. And then I take that 8 and put it back into x. So x is now updated to a value of 8. On line 9, I add 1 to y. Y goes from 0 to 1. And then where do we go? We go back to line 7. Okay, we go back to line 7 because we are at the end of the inner loop, so we have to go back to the beginning of the inner loop. The inner loop starts on line 7, so we have to go back to line 7 to reevaluate the condition. Y is less than 2. It's still true now. And then we move on to line 8. You guys okay? Okay. You can slow me down, just let me know if you want me to kind of slow down, because sometimes I go a little bit fast. Okay, so here's line 8 again, and we want to double the value of x again, because 8 plus 8 is 16, so we put 16 here. And then on line 9, we add 1 to y. Y goes from 1 to 2. We go back to line 7. And on line 7, y is less than 2 is now false, because y itself is also 2. 2 is less than 2 is false. There's one more thing to do, because after line 10 is line 11. In other words, when I get out of the inner loop, I have one more statement to do, because line 11 is sequential to the loop, from line 7 to line 10. So now I have to go to line 11. We add 1 to x. X goes from 16 to 17. And then where do we go? 2. We go back to line 2 because we are now at the end of the else branch of the conditional statement. So since we're at the end of one branch of a conditional statement, we get out of the conditional statement. The conditional statement is the only thing in the loop. Since I'm done with the conditional statement, I'm also done with the body of the loop. That's why we have to go back to the beginning, which is on line 2. Line 2 says, is x less than 20? Yes, it is, just barely. Okay, so we go to line 3. Line 3 is still asking the same question. Is x less than 4? The answer is false, because now x is 17. Then we go to the else branch starting on line 6. Line 6 is going to 0, or reset the value of y to 0. And we go to line 7. Y is less than 2 is true. Go to line 8. We double the value of x. It goes from 17 to 34. We go to line 9. We add 1 to y. It goes from 0 to 1. We go back to line 7, reevaluate whether y is less than 2. It is true. We go to line 8, we double the value of x again, so now it is 68. We go to line 9, we add 1 to y. Y goes from 1 to 2. We go back to line 7. Y is less than 2 is now false. We continue execution on line 11. We just add 1 to 68. It becomes 69. X is incremented to 69. Then we go back to line 2. X is less than 20. Oops. X is less than 20 is now false. And then we get to post. So this is what I'm expecting. Okay, if anyone adds line 10, line 12, or line 13 into, or even line 5 into it, I'm not going to take any points off this time, because it's the first time you have to deal with something this complicated. If anyone is missing line 2 prior to the post, points will be taken off, because that really is important. Because we don't really get from line 11 to end the program right away. We have to get back to line 2, and it is line 2's decision to end the loop. Okay, so this part is actually important. I have to take points off if that part is missing. Okay, any other questions? Yep.
I was just confused on line 11 where it ended up, because I got the answer, but in the beginning, I thought 11 went up there. So
line 11 went up.
Well, up in the very beginning.
Okay.
So I was just confused on, I guess, how would you draw it? Because
All right, that's a good question. Okay, so how do we, visualize or draw this algorithm? Because that really is the first thing you should do, is to look at this thing and at least in your mind visualize, how everything is structured, what is containing what, how do you get into this, how do you get out of this, and so on. So let's go ahead and take a, I'm gonna save this, and then we'll take a picture. We'll draw a picture of this. Graphics, Inkscape. I don't have a wireless mouse. Using a regular mouse to draw pictures is actually kind of hard. All right, so let's give it a shot. Okay. All right, so let's go back to the pseudocode itself, and you know what? I'm gonna try this. Probably won't work, but I'll give it a shot. Let's see if I can copy and paste into here. Oh, you know what? That works. Okay, that helps a little bit because I don't have to go flip-flop between the screens, the two screens. Okay, so now we can actually draw a picture. At the top level, how many statements do we have at the very, very top level? Two. We got two statements, okay, because we have the initialization of x and then the loop. In other words, if you look at assignment statements as files and all the other kinds of statements as folders, we have one file and one folder here. In other words, one thing that cannot have any components inside, and the other one is a container. It can contain stuff inside.
Do you consider like a declaration same as assignment then, or?
Say again?
Would you consider a declaration same as assignment statement, or no?
In C and Java, you can have those two, combined into one, but in this class, they're always separate.
Okay.
Yep. In fact, when I write programs, I don't use initialized declarations. I always, do the declarations, in the code itself. But that's a personal thing. We can do it either way. Okay, so if I draw a picture about this, I'm going to draw a picture like this. Okay, I'm going to have one little thing here to represent the small statement, and then the rest of my screen is going to be for the big one. Okay, the while loop. I'm just going to leave myself enough room to do that. So that's why it's kind of big and huge. Okay, so that's the general shape of the entire algorithm. It has one little thing to do and then one big thing to do. But that one big thing to do is itself a single statement. It is a pre-checking loop, which is a statement. It can contain other statements inside, but from at this level, it is one statement. Okay, so I'm gonna put actual text inside these boxes here. So we have x gets a value of 0 in here, and the other one within this big block here, what do we have? This is that a conditional statement, a post-checking loop, or a pre-checking loop? It's a pre-checking loop. We check the condition before we perform, an iteration. Do we know the general shape, the template of a pre-checking loop? I sure hope so. Okay. So we draw that here. Okay. So now we draw the picture of a pre-checking loop. Don't even bother with the, other stuff, the details of it. We're just going to draw a picture. I'm going to try my best to draw this picture in a way that's consistent with how I do it in other parts of my notes. Okay, I think that's okay. All right, and it has a body. In other words, there's stuff to do inside that loop. Okay, so we now draw the stuff that we do inside the loop. Give it as much space as possible because it has one other loop inside. And when this is all done, we are going back to the beginning of the outer loop. So it has to close the loop like that. And then we just complete the path here. Okay, close enough. It's not perfect, but good enough for the illustration here. How do I label this branch here? This branch that will take us all the way out to the exit. True or false? That's false. Okay, very good. So this is false, which means the other branch is going to be true. So when it's true, we get into the body of this loop here. What is the condition, by the way? How do I decide which way to go?
X is less than
X is
20.
less than 4.
X is less than 20. Yep, X is less than 20 is the question that we ask in order to determine which way to go. All right. So if I want to be extra clear, I'm going to add some, directional arrow here, just so that we know that we can, go out in this direction or go out in this direction, just to be absolutely clear. Okay. All right. I think I'm going to run out of space, but we'll see. What do we do inside this big block here? Okay. If I'm just going to draw a picture here. I'm going to delete it later. What am I going to do here?
Should do the if and then the other while.
What are the line numbers corresponding to this red block here? Line
3 through 11. No, 3 through.
It'll be line 3 to line 12. Okay. In terms of the line numbers, it will be from line 3 to line 12. This is the content of the outside loop. So I'm gonna draw the content inside here. How many individual things do I have from line 3 to line 12? If you look at it from the top level, from line 3 to line 12, how many? At the top level, how many statements do we have?
2, 3.
One. It's a single conditional statement. It's only one thing.
Also. Also.
Because line 3 is the beginning of the conditional statement, and line 12 is the end of the conditional statement. There's only one conditional statement. Remember, a conditional statement is like a folder. It can contain other statements, but at this level, it only shows up as one single folder. If you look at a while loop as a folder, that folder has a single subfolder, which is a conditional statement. Now, the conditional statement itself has multiple subfolders, but that's okay. We'll deal with that later.
Okay.
Okay. All right. So at this point, I'm going to draw the rest of this picture, and I'm pretty sure I'm going to run out of space, so I will zoom in to just that portion, and I can probably draw the picture a little bit smaller, so I don't run out of space easily. Okay. We'll give it a try. So now we are going from line 3 to line 12, which is a single statement. It is a conditional statement. Do we know how to draw a conditional statement? What does it look like? We come in from the north, and then we split the path. We may have something to do on one side. We may have something to do on the other side. What do we do after both sides are done? They join, and then they exit. Okay. Does it have anything that go back to the beginning to do something?
Yes.
The conditional statement
Oh,
itself?
conditional.
No. Okay, very good. So when we draw that picture, it should look like this. Okay? So we draw a conditional statement, and only the conditional statement at this point. One single entry point. It branches, on one side to do something, and after doing that something, it has to exit. And the other side looks about the same. So the other side looks about the same. It will branch out. We got something to do here, and when that's done, we are going to exit the loop. Yeah, it's not looking very good, is it? And I am going to run out of space too. That's okay. We'll just go ahead and. I have a way to fix that problem too. I'll show you guys. Yeah,
Zoom in,
absolutely. Yeah. Well, the nice thing about Inkscape is it is not a raster drawing program. In other words, it's not pixel based. It is a SVG. Is the file format that it saves to. It stands for Scalable Vector Graphics. In other words, the way it represents things is not saying, oh, this pixel is black, this pixel is white, and so on. It's actually just trying to remember, how do I draw this picture? Where's the beginning? Where's the coordinate of the beginning? Where's the end of that line? And so on. So it's completely scalable. You can zoom in as many times as you want, and it will still look, smooth and nice. Okay, so that's how I'm going to solve this problem. Okay, okay. Let's continue with this picture here. The condition of the conditional statement is what? What is the condition of the conditional statement?
If X is less
If
than 4.
X is less than 4. Okay, very good. So X is less than 4 is the condition. And this is
True.
just conventionally in this class, we use the left one for true, and then we use the right one for false. Okay, let's deal with the easy one first. When it is true, X is less than 4, what do we do? Which line do we go to first?
The X. X
We go to line 4,
Oh,
X gets
X.
X plus 1.
1.
Okay, very good. So X gets X plus 1. All right, so that's good. Easy to do. Now we worry about this part here. So once again, we zoom in. Now, I think this is really a nice illustration because the zooming in part is exactly why we have nesting. Okay, so that we can specify more details at a lower level, basically. Okay, so this block here is corresponding to which lines? This is the else of the conditional statement.
5 through 9.
I would call it 6 to 11.
Okay.
It's the entire else branch of the conditional statement. So the else part starts on line 6, y gets 0. It ends on line 11, which is x gets x plus 1.
Because 5 is not doing anything.
Because
It's not doing anything on 5, it's just saying else. Like,
yeah, line 5 is really just it's a syntactical thing to
Yeah.
separate the then part from the else part, because otherwise it's one big blob and I cannot differentiate where's the end of one and the beginning of the other. But when we draw a picture, else really has nowhere to go because there's nothing here to correspond to the word else. Okay. All right. So from line 6 to line 11, how many things do we have? Looking at it from that level. In other words, if I just focus my attention to these lines here, how many statements do we have at the top level?
2?
3. We have one file, one folder, and then one more file. Right?
English.
Yeah.
English.
Line 6 is an assignment statement. It is a file because it cannot contain anything else.
Okay.
Line 7 to line 10 is a while loop. It is a folder because it can contain additional statements. And then line 11 is just an assignment statement. It cannot contain other statements inside, therefore it is a file. So we have file, folder, file, from line 6 to line 11. So what we'll do is we'll emphasize that really is the case by drawing a picture accordingly. Okay, so we'll go ahead and say, okay, we got one little thing here, and then we got one bigger thing, which is our loop, and then we got one more little thing down here. And this time I'm going to be lazy and try this out. Okay, Control D for duplicate, go to Object, and say flip. And then we drag whatever we just flipped. Now we have symmetric stuff, okay? Symmetric. Okay. It's not fancy, it's just being lazy and not having to deal with the other half. All right, okay. And so we want to label the the easy ones first, okay? The files are easy to deal with, or the individual assignment statements are easy to deal with, so we're going to deal with that first. And I have to choose a smaller font now because the picture is getting smaller. That is bigger, too big. Let's pick size 10. Okay, what do I put here? Where the blinky cursor is.
Y takes equal.
Y gets
0.
0. Very good. So Y, oh, that's too big. Even that is too big. 8. Y gets. There we go. Y. And we'll change the font. There we go. Y.
I think it changes the background.
Okay, we got it. Y gets a value of 0, and then down here we have x gets x plus 1. And we want to choose smaller font. There we go. Okay, now we zoom in and say, well, but what about that big block in the middle, right? Okay, so let's take a look at the big block in the middle. We zoom in to just this portion here. And which lines are we talking about in this big empty space here?
7 to 10.
We're dealing with line 7 to line 10. Very good. And what is that?
The folder.
It's a folder. And what type of statement do we have here?
Y.
It's a pre-checking loop. Okay. And do we know how to draw a pre-checking loop?
Yes.
Sure we do. Right? We just did one before. And this time we're going to draw it again, but when we draw this one, I have to use a thinner line. So let me do some of the setting here, go to stroke style, and make it a 0.5 pixel line. So it's, it's a little bit thinner. Okay, so we draw a loop here. It has a way to come back from the end of the statement. And here's our exit branch. Okay, I didn't leave myself enough space. Okay, do it again. Okay, this is the re-entry point. I have to leave some space here so I can get out of the loop. Go back to, I would say about here, and here's my exit path. Right there. Okay. And now here's the completion of the exit path. And then here we have the exit point, the re-entry point back to the beginning. All right. I'm getting a little bit better at this. Okay. I think that's enough space. All right. Since this is a pre-checking loop, let me just kind of point out the directions. So we have, we are coming in from the top here. We can either go this way, or we can go this way. And, this is just, a path going in this direction. Okay. I know it's not looking very good. So what we'll do is we'll select everything here and make the lines thinner. Now it looks good again. All right. So this is the structure of a pre-checking loop, which is the same structure as the outer loop. Okay, it has exactly the same shape, except in this case, the way I label it would be slightly different. So this time I need it even to be smaller. So we'll pick 6 point here. This is the label that is labeled true. This one's going to be labeled false. And what question do I use to determine which way to go? Let me go back to the code here.
Y less than 2.
Y is less than 2 is the condition to evaluate. Okay, so we have y is less than 2 is the condition to ask. And I think even that is a little bit too big, so we'll use 4. Okay. All right. What do we do inside this loop here? I'm not going to draw any more blocks, because there are 2 sequential assignment statements, so I'm just going to type out the assignment statements. If I switch back to the source code, what should I write here?
Y is assigned x plus x.
Okay, x gets x plus x, and then the next line is y gets y plus 1. Okay, very good. So x gets x plus x, and y gets y plus 1. All right. Do we have anything else left over? Do we have any more nesting in this particular example? This is it, right? So let's take a look at the whole thing and see what it looks like when we go all the way out to the top level. One more. There we go. So now we have the whole picture. Yeah, I know it's pretty hard to read the tiny little loop in the inside, but that's exactly what it is. This really shows the limitation of graphical type of programming because it's just not as condensed as pseudocode. Okay. So are there any questions about this particular one? You guys want me to save it?
Sure.
Maybe. Not interested. I'll save it. I'll create a folder for today, and then we'll save it. Okay, so now we have a folder. Click, and we'll say this is for assignment. This is the nested assignment. So once I have it saved, though, you can remind me to upload it later to Moodle, do whatever we want. Okay. Are there any questions about this? Are there any questions about how the picture was drawn? Okay, you know, the detail is not even important. Okay, it's not even important, you know, about the labels and stuff like that. It is the approach, how I drew that picture. Okay, I go from the outside, I go inside, you know, a little bit, look at, you know, the statements at that level. Okay, once I'm done with that level, I go into even more, you know, deeper into the picture. Yep, go ahead.
Notice that in the first while,
Mm-hmm.
you kind of broke it out like with the basic loop there, and then you had the exit for the fall. So then in the second while,
The inner while.
yeah, the inner while with the X with 4, kind of broke it up into two big blocks there.
Okay.
With one.
Okay, let me try to zoom in a little bit more. Okay, so you have the two loops look exactly the same. They have one entry point from the north, one exit point, and then a point where you have to make a decision: should I go for another iteration, or should I get out of the loop? And it's the same way as the one in the inside. It's just, you know, in the inside, but it's really, it has the same structure. Okay. All right. So are there any questions about how the process of drawing this picture? It is the process itself that is the most important, because, you know, this is how you can picture the structure of a program in your mind. Because, you know, when we keep going in this class, you know, I'm not going to draw pictures anymore. Okay, so you will have to come up with the picture, or at least a mental understanding of what is inside what and what to do, you know, at the end of a particular statement. So this is something that you will have to kind of develop on your own, you know, when you know, read the code more. Okay. All right. So let me just, you know, close this. I saved it already, so I can actually upload it later on. And from the questions that I'm getting, you know, from this class, and also from the other class, you know, because I'm teaching the AM class too, and they have a similar homework assignment about nested statements. From both classes, you know, I kind of get a sense that, you know, we need one more homework assignment, you know, just to get enough practice on this sort of thing. The second assignment is actually easier, okay? So we'll take a look at more nested.
Make it easier.
Hmm?
Why did you make it easier?
Well, it's easier in a way, you know. It's just like that, okay? So you guys can tell me whether it's easier or not. Yep.
Don't you just end it because there's no y value?
Hmm?
Don't you just end it because there's no y value?
There's no y value?
You go to this comment sheet.
In sheet 2, oh, you're right. Y has no specific value. Okay, we'll just add that. Thank you. So insert one column for y, and we'll make y start with 0. Thank you. Very good. Good job. You got it. Okay, so now I have to update the homework assignment. So anyone who has started already, you have to re-download and then do this whole thing again. Okay, so it's pretty easy, you know, from my perspective to re-upload it. Choose file, go to my downloads folder. It's called More Nested. Oh, I think I put it into the temp folder. No?
No, you did download it, but it was only called a nested.
Maybe I named it incorrectly. No, that's the wrong one. Okay, where did I download it? All right. Well, that's easy to find out. Go to here, go to properties, and now it shows me it's under APK tool. Okay, completely irrelevant folder for this class. APK tool,
Right there. You're right there.
lowercase APK. Yeah, because uppercase are listed before lowercase. That's how, you know, the ASCII code is structured. So we have more nested here. And let me close it first on the other side. Okay, now we can just re-upload. Overwrite, update, and don't forget to save. There we go. All right, so just to double check, I'm gonna do a Control R to refresh. And then click on this again, and save it again. Open it one more time, and now this is correct. Yay. All right, so the question now is, is this easier? I think it's easier, okay? It's kind of strange, if x is greater than or equal to m, we subtract m from x. And then y gets y plus 1. But regardless, we're going to add k to x before the conditional statement. So I think in terms of the trace, this one's going to be shorter. And you kind of have to figure out what it's doing. This loop actually has a very useful application of drawing lines back in the good old days when we don't have GPUs. Yep.
Quick question for this loop. So like when y is less than when y is less than 3 is false, you don't go to this statement, right? You just end, you post.
It says while y is less than 3 do, which is the same thing as saying as long as y is less than 3 do the following.
Otherwise just post.
If y is not less than 3, you get out of the loop. Remember, it's a pre-checking loop. To get out of the loop, the condition has to be false. To get into the loop, to perform one iteration, the condition has to be true. Okay. Any other questions about this new homework assignment? You have 1 week to work on this. Okay, I don't think it's going to take nearly that long now that we have kind of talked about the nested statements. Any other questions? No other questions? All right, if there are no questions, we'll go back to the pre and the post conditions. And last time we ended, we talked about the inverse function thing, okay? So we'll go ahead and, I'm just going to go here just so that we know where to find the notes when you're studying. But in terms of the lecture, what I'll do is I'm going to kind of deviate from my own notes, even though I'm going to go for exactly the same material, okay? All right, so let's take a look at line. Okay, even the line number is going to be abstract here. Okay, this is line n, and the assignment statements look like this. Okay, we have a variable v on one side, and then on the other side we have let's say a function of v. Okay, f of v like that. Okay, so this really captures the overall format of any assignment statement in a program. Okay, so let me just kind of bump up the font size so we can see a little bit better. There we go. Okay, so once again, let me just re-explain it. N is the line number. Okay, I'm just calling it line n instead of a particular line. V is not a real variable. It's just whatever variable we specify on the left-hand side. And f is just a function to represent the right-hand side. Okay. So let's take a look at some specific answers here, because what I want to do is to develop a set of rules so that when we just look at an assignment statement, we automatically know what to do with it, so that we can go from the pre-condition to the post-condition. Okay, that's what we want to do. We want to make it very mechanical. You evaluate an assignment statement mechanically, and then you come up with whatever rule you have to apply, and then you apply the rules also kind of mechanically too. Okay. So let's take some actual concrete example here. All right, so we'll take a concrete example of line 34, and we have variable x on one side, and we have 0 on the other side. Okay, so in this case, n is 34 because n is representing the line number, and variable v is actually x. And what about f of v, or f of x, if you will? F of x in this case is just 0. Whatever is on the right-hand side is f of x. Are we doing okay so far? Is there a problem with f of x being 0? No, as a function, it's okay. It's not a problem at all. Can anyone tell me what a function is in mathematics?
Basically an equation.
Just in general.
It's basically an equation.
It's not an equation, it's a mapping, right? It's mapping, in this case, whatever value of x to some potentially other values, right? Okay, very good. Sorry, should have let you say it first. Okay, so if you look at, a graph, okay, so if you look at a graph, typically we have the horizontal axis being x, and then the vertical axis, sometimes we call it y, but I'll just call it f of x, okay? Yep.
Isn't it just one input for one output?
Not, you can have multiple input and only one output, but most functions only has one single output, but you can have multiple input. But in this case, it only has one input, which is the variable on the left-hand side. Okay, so because that is the most important variable that we need to focus on. Okay, all right. So if you look at this function here, f of x equals to 0, what do you think this graph looks like? What happens when x is 0? F of x is 0. What happens when x is 1?
0.
F of x is 0. So that means this function is really plotting a horizontal line at the value 0. Okay? Is that okay? Okay. What if? Okay. Let me just kind of change this, to something else. I'll use another example, another concrete example here. This is line 61, and this is x gets x. Okay. And obviously the line number is 61. The variable being changed is x. F of x in this case is x because it is just whatever is on the right-hand side. If I were to plot f of x equals to x using this picture here, what would it look like?
45 degrees.
It's a 45-degree line. Very good. Okay, so it's a 45-degree line, which means if I pick a spot here, whatever value here is going to be whatever the value is here. Okay, very good. So we know what a function is. A function is really a mapping. Okay, you give it something, it maps it to another value. Are we doing okay so far? Okay, so there's no problem with having a constant as a function because all that means is, oh, give me whatever x, I'm going to give you exactly the same answer every single time. In this case, on line 34, f of x is 0, which means give me any value of x, I'll give you 0. It's not a problem. Okay? Well, not a problem per se at this point. Okay. Getting back to here. So the next question we want to ask is there an inverse function? Okay? Okay. F of x is 0. Does that have an inverse function? Now, what an inverse function does is if you give it f of x, it can figure out what x is. That's an inverse function. You're reverse mapping it. In this case, there's no inverse function. Why is there no inverse function?
You never go back to the value of x.
Because there are multiple values of x that can map to exactly the same output. Every single value of x will map to 0. So if you tell me the result of f of x is 0, and then you ask me, okay, knowing that f of x is 0, tell me what x was. I don't know. It could be anything. And that's why it doesn't have an inverse function. Because an inverse function has to go back to a single value. Okay? You give me f of x, I can give you a single x corresponding to that f of x. That is an inverse function.
One-to-one.
One-to-one correspondence. Exactly. Okay? So in this case, has no inverse function. Okay? In fact, if you look at the right-hand side, if the right-hand side does not mention the variable on the left-hand side, it has no inverse function. Because what it's telling you is the right-hand side does not depend on the right-hand side at all. And if there's no dependency between the two, there's no way it can be mapped or reverse mapped. Are we doing okay so far? Okay. What about this one here? If f of x, is there an inverse function? Is there a way to go back?
Yes.
And that would be is just x itself. In other words, if the function is, I'm trying to pick a different color. I got the blue. Okay. So if we focus on the blue line here on the whiteboard, if I say, oh, this is f of x is here, okay? F of a particular x is here. Can I figure out what this is? What is it mapped to? I can reverse it, right? I can just extend this, hit this line, drop back to here. So if I say this is, if f of x is a particular value, we call it y here, this is y itself. We can reverse it. Okay? Is that okay so far? What about x plus 1? Do you think that's reversible?
Yes.
Okay. I mean, obviously, line 61, like in this case, is not very useful in a program. So we don't want to use that as an example. But x plus 1 is a very useful type of right-hand side. So we'll take a look at that one. Okay, we'll take a look at line 7 here. And it is x gets x plus 1. So in this case, the line number, which is just n, is line 7. The variable being changed is x. It is whatever is on the right-hand side. I mean, excuse me, whatever is on the left-hand side. F of x is really just the right-hand side of the assignment. In this case, it is x plus 1. The inverse function of this is x minus 1. Okay. All right. So an inverse function that does exist. So I'll just kind of focus on that part here. So I'll say an inverse function exists. It is f prime equals to x here. In this case, I would say about the same thing. An inverse function exists. It is x minus 1. Now, as it turns out, whether an inverse function exists or not is a big deal. Yep.
Going back to the graph,
Mhm.
would that be y or the inverse of y?
It is the same, right? Y is its own inverse. Sorry?
Is it in this particular case or is it in
No, y is really just a value. So if you don't want to use y as a name, you can just use k here. In other words, if the y-axis has k, and I want to map it to, okay, which value will give me a result of k? It is k itself.
So in this case, whereas fx equals x, right?
Correct. Now, what would the picture look like when f of x equals to x plus 1? Let me just erase this picture and start all over. Because I just want to make sure that you guys can see it, as a visual thing. Okay, so once again, we have x, y here. So x versus f of x. This is 0, 0. Okay. So the function f of x equals to x plus 1, what does it look like? When x is 0, what is f of x? 1. Okay. And when x is negative 1, what is f of x? 0. Well, that's all I need because it's a linear function, right? So that function looks like this. An inverse is basically saying, if I can give you the value of f of x, can I figure out the x that gets me the value to this point? And the answer is yes, because I can project this point here to this point here, and then I can then project it back down here. So if this is k, this would be f prime, or f inverse function of f applied to k. Is that making any sense? Kind of. It's basically, it's which way are we looking up? The function itself is telling me you start with the horizontal axis, and then we figure out what we should be having for the vertical axis. The inverse function starts with the vertical axis, and then we are going back to the horizontal axis. So a lot of functions are both ways, okay? Especially in programming, a lot of functions are both ways. Like x gets x plus 1 is a typical case. It can go either way. Are we still doing okay so far? Okay. There is one thing I did not mention here, okay, which is very important. When f of x has no inverse function, that means we cannot reverse the operation on line 34. That's a big thing. It's a really important aspect of f of x having no inverse, because we can no longer maintain the relationship between the variables. Okay. Let's talk about the cases where we have an inverse first, and then we'll go back to this one and say, yeah, that gives us a lot of trouble because we cannot go back. Okay. So I'll just go, I'll just write down here, okay? Now we talk about some rules. Okay. So once again, I use the most general form, which is on line n, we have a variable v getting a function f of v. Okay, so we'll just copy and paste it here. Okay. So I'll just say that if an inverse function f prime of v exists for f of v, then we use a substitution rule. I should have said the. Okay, we use the substitution rule. Okay, what does that mean? That means the post condition of line n. Now this is important. I'll explain. It's kind of abstract at this point, but once I give you some examples, it will be pretty clear of what it is. It's a substitution based on the precondition of line n. Whatever occurrences of v we see in the precondition of line n, we substitute it with f prime applied to n, applied to v. That's it. That's the substitution rule. Okay. By itself, it doesn't say a whole lot. It's really, really abstract. What is v? What is f prime of v? And what is pre-n? Okay, we'll go through some examples. Okay, so I'll just give you guys a moment to kind of absorb this first. Okay, so I'll say that one more time in words, and then we'll do it, do an actual example. Okay, so I'll say it one more time in words. The post condition of line n is based on the precondition of line n, except we take all occurrences of variable v, which is the one on the left-hand side of the assignment statement, and substitute every single occurrence with f prime, the inverse function of the right-hand side of the assignment statement, with f prime of v, the inverse function, applied to v. That's a mouthful. Okay, but what it really is doing is just saying, hey, we don't have to destroy what we knew about the variables. We can apply a transformation, f prime, to the variable that was affected by line n, so that we can reestablish the relationship between variable v with all the other variables or constants. So we'll go through some examples first. Okay, we'll do some simple ones first, and then we'll do something that may be a little bit more complicated. Okay. Example to apply the substitution rule. So from now on, I just call it the sub rule, for substitution. All right. So we'll just go take this one again. Okay. So I'm going to copy and paste it. All right. So the first question we have to ask is, the right-hand side is f of x, which is the general function thing, is x plus 1. Okay, because whatever is on the right-hand side, I just call that a function of the variable on the left-hand side. Is that part okay? Okay. Does it have an inverse function? Does f of x has an inverse function in this case? It does. Very good. So f prime of x, I'm using f prime instead of f superscript -1 because I cannot do that easily with the text editor. So f prime of x is the inverse function, is x minus 1. Okay, so now we'll go ahead and actually apply that rule. So we'll say post 7, the post condition of line 7, is based on the precondition of line 7. We substitute all occurrences of the variable on the left-hand side, in this case it is x, with f prime applied to x. Okay. Of course, in order to make this work, I have to tell you what is the precondition of line 7. So let's go ahead and make this kind of simple. We'll just say that we know for sure that x must have a value of, let's say, 5 right before we start execution on line 7. Okay? All right. So the next step is oh, since we know what is pre-7, we'll just put it here. Pre-7 is x equals 5. That is something that we knew about x before line 7. X is just x. What is f prime of x again? It's x minus 1, right? Okay. So now, you can see the first step here. This is really just straight out of the template, okay? It applies to just about any situation when an inverse function exists. The second line is based on the first line, except, we substitute pre-7 with the actual condition of the precondition of line 7, and we substitute f prime of x with the actual expression that expresses, f prime of x.
This is kind of sort of similar to what we were looking at earlier in terms of.
It's just formalized.
Okay.
Mm-hmm.
Yeah.
It's just formalized, and basically I turn something that we used to think, okay, we have to think in these steps, I'm just making it mechanical. Okay, which is good. Mechanical is good. All right, so now we actually perform the substitution. Okay, so that means, whatever x is, okay, let me just write the entire thing out first. We take all occurrence of x, in this case we only have 1, and substitute it with x minus 1. That's all. That's why it's called the substitution rule, because we substitute the variable on the left-hand side by f prime applied to the same variable. Okay. But what does it mean? Well, let's finish this one first, and you tell me whether it makes sense or not. Okay. And using algebra, I can add 1 on both sides of the equality. So now we have x equals 6. Does that make sense? X was 5 before. The statement is adding 1 to x. X becomes 6. Seems to make sense to me. But how does it work? Remember what I said earlier? The way it works is f prime, the inverse function, is basically just a way to say, well, if you tell me the value of x after the operation, I can tell you the value of x before the operation. That's what it's doing. It's basically an undo to the statement in question. In this case, statement 7. Okay, so that's nice to have, being able to reverse the operation. But why would I want to reverse the operation? Because I want to maintain what I knew about the variables as much as I can. In other words, pre-7 is telling me how x relates to everything, okay? How it relates to the other variables. In this case, it does not have that component, but it does tell me what I know about x already. So if that's something that I know about x, and I can reverse the operation after line 7, then I can actually use this as a basis in order to come up with the new statement of what I know about x after the operation. Is that okay so far? Okay, so let's take a look at something that is a little bit more complicated, not by much. Okay, so let's take a look at another example. So this time we'll take a look at a concrete line number. Let's say this is line 11, and on line 11 we have let's not use x because we have used x too many times. Let's use z in this case. Okay, variable z is 2 times z plus. Okay, I would still continue to use solid numbers or concrete numbers, so this way we can actually verify the result. Okay, so that's it. Okay, it's 2 times z, 2z plus 3. Okay, so we have to ask the same questions. Okay, first of all, we say the right-hand side is, in this case, f of z, because we are no longer dealing with x here, is 2z plus 3. Does it have an inverse function? In other words, if someone gives me this particular function, give me a plot, is it possible for me to start with the vertical value and map it back to the horizontal value? Yep.
Z minus 3 divided by 2.
Z minus 3 divided by 2, the whole thing divided by 2. Okay, that's absolutely right. Okay, f prime of z in this case is z minus 3, the whole thing divided by 2. It has to do with the chaining of the functions because f of z is actually 2 functions combined. So if you look at each individual function, it has its own inverse, but you have to apply the inverse in the reverse order. And that's why we have z minus 3, because the last operation gets inverted first, and then the first operation gets inverted last. It's kind of like a stack thing, last in, first out. Well, the question is, does it work? I don't trust you, tag. Prove it, right? So it should be provable, right? Now something like this, is provable because you can apply f to f prime and then apply f prime to z. We want this whole thing to come up to z, okay? But I cannot just claim it. I have to prove it. So what I will do is I'm going to say, okay, we'll deal with the inside first. What is f prime applied to z? That's easy. We just talked about that, right? Are we doing okay so far with this step? I'm just expanding what is f prime of z. Is that good? Pretty much by definition. Okay. Then how do we apply f to it? What does it mean when I say apply f to blah? When I say apply f to blah, I mean twice, double the value first, and then add 3 to it. Is that okay? So let's go ahead and do it. So I say 2 times, okay, whatever junk I have in here. Okay, one too many parentheses, and then just add 3 to it. Is that part okay? That part, it has no algebra whatsoever up to this point. It's really just copy and paste, right? Okay. Now we have to apply algebra to see if we can get z back. All right. So how would you do this? You can change the operation, right? You can do the multiplication by half, first, and then change use the associative rule so that you have 2 times 1/2, which cancels out. It becomes just whatever is in the inside. You guys know what I'm talking about? No, kind of.
Yeah.
Okay. All right. Okay. I'll just be a little bit more clear in this case.
Can you scroll up?
Oh, sorry. Just hold on 1 second. Can't scroll up because it's the last line already, but I can do that. Right? In other words, instead of saying z minus 3, the whole thing divided by 2, I say 1/2 times z minus 3. That's the same thing, right? It's just reversing the operands of multiplication. And in algebra, how do you call that?
Reciprocal.
No. Changing a times b is b times 1. B times a. What is the name of that axiom in algebra?
Why don't you just explain that the c minus 3 is being divided by 2, then it's being multiplied by 2, so nothing's happening?
Well, because I want to do this step by step, like in an algebra class. Because we have to cancel out the 2 with the half, right?
Yeah, well, isn't it more simple saying, if you multiply something times 2 and then divide it by 2, what happens? They're the opposite.
But that would be skipping one step, isn't it? Because because this is the same thing as multiply by 1/2. So we have to first move the half here. Okay. Good thing I'm not teaching algebra. Okay? So, okay, from here to here is the commutative rule in algebra. From here to here is the associative rule in algebra. This is the identity rule of algebra for multiplication. Right? And because this is identity, we have z minus 3 plus 3. And then once again, we switch the order. So it becomes z plus -3 plus 3. But we can group these two together using the associative rule. And that becomes z plus 0. And then we use the identity rule again and say that z plus 0 is just z. In an algebra class, that would be the proof. I know it is intuitive. I know you guys can look at this and go, yeah, it's obvious. But remember what I said about obvious from the previous class?
No trust.
Okay. But this, I don't think anyone can dispute it and say, oh, I think you got one of the steps wrong. Okay. So I'm just, yep, go ahead.
Do you have that roll sheet yet?
Roll sheet, yeah, that's right, forgot about it. There we go. Yeah, we have enough time, about 5 minutes. I'll just drag the lecture out as much as needed, in order for the roll sheet to get passed. Okay, but we just proved it, right? We have, an inverse function. Now it should work the other way around too. In other words, if you apply f prime to f and then the whole thing to z, it should get back to z as well, okay? Because that's a property of the inverse function. You can apply it first, or you can apply it second, and it will still get back. It will still get back to z in this case. Okay. So after this long discussion here, we have established that we have an inverse function. Good, because that means we can apply the substitution rule. So the substitution rule, if you look at it just from the syntactical perspective, or just manipulating symbols perspective, it's really just saying this: post 11 is based on the substitution of pre 11. We take all occurrences of the variable on the left-hand side of the assignment, which is z in this case, and replace every single one of those with f prime applied to the variable z itself, and that's the format. Okay. So in order to make this meaningful, I have to give you a pre-11 first. So in this case, I will give you something that's tricky. Nothing. Well, let's still deal with something concrete so we can actually verify the result. Okay, so I'll just give you something like z has a particular value, which is 3, and this time I'll give you something that is completely, independent of z, and also something that has to do with z and another variable. Okay, let's say z was greater than w before that line. Okay, so we'll take a look at the second step of the substitution rule. You take whatever is in the precondition, which is this entire thing here, just stash it here, and then you repeat the rest. But you also have to remember what is f prime of z, the inverse function itself. We got it all the way up here. So we just, I put parentheses around the whole thing, so you can go anywhere, without having to worry about, oh, it's going to mess up the original equation. The last step is to do the actual substitution. To do this actual substitution, you just take the precondition itself that is already expanded, and every time, okay, I'm just going to copy this into the clipboard. Every time you see z, you replace. Every time you see z, you replace, and we're done. Okay? It's completely mechanical. The only part that is not mechanical, that requires some thoughts on your own, is to come up with the inverse function. And some functions, even though it looks like it has an inverse function, it does not, or it has a really kind of funky way of looking at the inverse function. But is this part okay so far? Now, if you want to take it one step further and actually finish up the calculations, you can if you want. I mean, you can definitely do it here. So in this part here, you can basically say that z is 2 times 3 plus 3. Okay? And x is less than y cannot be simplified any further. And this one here, I don't really feel like simplifying it, because it doesn't buy me anything to simplify it. That. And so here we have z equals to 9. Is that right? Okay. Z was 3 before, and then we go through line 11. Should I get 9 back? Yep, it works out. Okay, it does work out. But what is more amazing, I mean, you can say that, yeah, well, we can just trace the algorithm and know that z is 9 after line 11. No big deal. Well, you're absolutely right about it. When you have concrete values, you can just trace it. But what if you don't have concrete values like this? I'm just saying that z was greater than w before the assignment statement. Now I can say this, okay? I'm still relating z to w, I'm just changing it a little bit. Am I making the point here? Very good. So now the big question is, what if there's no inverse function? And also, I just want to point out one tricky one that has, technically speaking, it has no inverse function. what? X gets x times x has no inverse function? Isn't it really just the square root of the result? It's not. Remember what it looks like, okay? If you plot, f of x in this case, what do you get? You get a parabola, right? Okay, it looks like a cup. Okay, if you start with a horizontal value, like here, you can say, okay, it maps to a particular, vertical value, right? Okay, done, no problem. On the other hand, if you start with a vertical value, you say, oh, it maps to a single value. No, we're forgetting something here, aren't we?
The other side.
Because it goes to the other side too. So now you have two values coming back from a single value. So technically speaking, it is not an inverse function. Okay? Basically, in the case like this, as a post condition, you have to say positive and the negative of the root. Okay, you have to split it into two cases because x can be the positive root or it can be the negative root. So that's a tricky one, and there are more tricky ones too because they don't look like tricky ones, but it is kind of tricky. Well, it seems like we have a function of x because I mentioned x twice even on the right hand side. But what is x minus x?
0.
It is always 0, right? In other words, this function f of x is x minus x is mapping every single one onto 0. So if you give me and say, oh, I know after this operation x becomes 0, but what is x before this operation? I cannot tell you anything. And that's why it is not reversible. There's no inverse function. Okay? So the big question now is, what if there's no inverse function? In other words, we're now going all the way back here. There's one example that has no inverse function. Okay, right here. What if there's no inverse function? Well, I encourage you guys to read the notes. It is the forget rule, okay? Unfortunately, there's no easy way to handle this one. So the general approach is to say, forget what we knew about this variable. Yep. Yep. All right. So we are running out of time. Does everybody have a chance to sign on the roll sheet? Here. Okay. So I'm sorry you guys have to wait a little bit just so that you can get your name on it. But don't forget, if you want to add to the class, get the add permission and also get the petition form on Thursday so I can sign it. Let me turn off the recording first. And then